Okay, so in this video I'm going to have a look at the Leaving Cert Higher Level Maths Paper 2 questions 1 and 2, and this is for 2017. So first one here is, let's see, when Connor rings Ciara's house, the probability that Ciara answers the phone is 1/5. Connor rings Ciara's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, 4th and 6th days, but not on the other days. Okay, so on day 1 then she doesn't answer the phone, so the probability she doesn't answer the phone is going to be 4/5. So that's going to be 4/5, and then we want her to answer the phone on the 2nd day, so that's going to be 1/5, and we don't want her to answer the phone on the 3rd day, so that's going to be 4/5, and this is 3. On the 4th day we want her to answer the phone, so that's 1/5 that she will answer, and the 5th day then she won't answer the phone, so that's 4/5. 6th day she will answer the phone, so we got 1, 2, 3, 4, 5, 6, and one more then she won't answer the phone on the 7th day. So when you multiply all this out you get 256 over 78125. 78125. You can write that as a decimal as well. I've kind of rounded it here, but it's 0.003278. That's it really. This is the probability that she will answer the phone on the 2nd, 4th and 6th days, but not on the other days. Okay, let's have a look at the next one then. Find the probability that she will answer the phone for the 4th time on the 7th day. The 4th time on the 7th day. So this is going to be a Bernoulli trial, and it's kind of an extended version of the Bernoulli trial. She has to answer the phone for the 4th time on the 7th day. So the way we do that is we use our formula for the Bernoulli trial, which is and choose or p, which is the probability of success, to the power of or, and then q, which is the probability of failure, and that's going to be to the power of n minus or. Okay, so in our case our n here is, now we want to find the probability that she will answer the phone for the 4th time on the 7th day. Now the way we're going to do that is work out the probability that she answers the phone 3 times in 6 days and then answers the phone on the 7th day. So that gives us 4 answers, if you like, 4 answers of the phone, if you like, on the 7th day. So let's have a look. We have n here, which is, we're going to work out for 6 days the probability that she will answer the phone 3 times in 6 days, so that's 6 choose 3. The probability of success then that she will answer the phone is 1/5, and that's going to be to the power of 3, which is our or here, and then the probability of failure here, which is q, is 4/5. That's going to be the probability of n minus or, so 6 minus 3, which is 3. So this is the probability that she answers the phone 3 times in 6 days, and then means multiply, she will answer the phone on the 7th day. This gives us our 4th answering of the phone, if you like, on the 7th day. So this is the probability that she will answer the phone on the 7th day, or on any day actually, is 1/5. So we just multiply by 1/5 here. Now when you work all that out you get 256 again on top, and you get 15625, 15625 on the bottom. And again, as a decimal, if you need it as a decimal, it's 0.016384. This is the accurate answer here anyway. Okay, it doesn't say that we need it to give our answer as a decimal or to so many decimal places or anything like that, so really this is it. Same up here, this is our answer here. Okay, next one. Connor rings her house once every day for n days. Write in terms of n the probability that Ciara will answer the phone at least once. Well, now we don't know what n is, so we can't work out individual probabilities up to n because we don't know what n is. So the way we would do this is work out the probability that she doesn't answer the phone in n days. So she's not going to answer the phone, and then do 1 minus that probability. So really what we're going to do is this: 1 minus the probability that she doesn't answer the phone, so in n days. So it's going to be n choose 0, so she doesn't answer the phone in n days. The probability of success again is 1/5 to the power of or here, which is 0. Probability of failure is 4/5, and it's going to be n minus or, which is n minus 0 here. So this is our probability that she will answer the phone at least once. This is the probability that she won't answer the phone at all in n days. So we're just doing 1 minus that probability. That means we're working out the probability that she will answer the phone at least one time. Okay, so when you work this out, you will get 1 minus well, n choose 0. N choose 0 is just 1. 1/5 to the power of 0 is 1 as well. Anything to the power of 0 is 1. So what do we end up with here? We end up with 4/5 to the power of n. 4/5 to the power of n. So that's really it. I mean, you could you could maybe do something like this: 4 to the power of n over 5 to the power of n. Maybe add these two fractions. That'll give you 5 to the power of n minus 4 to the power of n over 5 to the power of n. But really, this is where I would be more inclined to finish. So let's move on to the next part of the question then. So I'm going to use this part here rather than this in the next part. Find a minimum value for n for which the probability that Kira will answer the phone at least once is greater than 99%. So at least once. This is the probability that she will answer the phone at least once in n trials, or in n calls, if you like. So or n number of days. So we want this probability to be greater than 99%. So what you're going to do is write down 1 minus 4/5 to the power of n. We want this to be greater than 99%. Now remember, we're dealing here in fractions or decimals here, if you like. We have fractions here, so we need to convert this to a decimal or a fraction. I'm going to convert it to a decimal, so 0.99. Now let's just work this out. We got to work out n, the number of find a minimum value for n. Got to work out the minimum value for n. So the minimum number of days, in other words. So let's do this. So subtract 1 from both sides. If you subtract 1 from both sides here, you'll get minus 4/5, 4/5 to the power of n, greater than minus 0.01. Next thing I'm going to do is I'm just going to multiply across by minus 1. So that'll give me 4/5 again to the power of n. Remember, because we're multiplying across by minus 1 here, you must switch this around. So I'm going to switch that around here, and this is going to be 0.01 on this side. Okay, so now because our power here is the variable that we want to find, we want to work out what n is. What I'm going to do is get the log of both sides. I'll get the natural log, so ln 4/5 to the power of n less than the log of 0.01. Now again, using the rules of logs or the laws of logs, I can take that n and bring it down here. So what I end up with is n times the log of 4/5 less than the log of 0.01. I'll just move up here now because I'm just running out of a bit of room. So let me see. Up here I'll end up with, what I'm going to do here now is divide across by log 4/5 because I want n on its own. So I'm going to end up with n here. Now if you work at the log of 4/5 on your calculator, you'll see that it's a negative number. So this is a negative number we're dividing across by. So that means we're going to have to flip around this inequality symbol here. So what we end up with is the log of 0.01 on the right hand side divided by the log of 4/5. So this is all of this you can just do on your calculator. It's fairly straightforward. So you get n being greater than 20.6377 and so on. So we were asked to find the minimum value for n for which the probability that Kira will answer the phone at least once being greater than 99%. So the value of n would have to be, n has to be greater than this here, so it's going to be, and remember n is a discrete value, it's the number of days, so it's going to be n is equal to 21. Okay, so that's the answer to part D. So let's have a look. Actually, that's the answer. That finishes question 1. So we're now on question 2 here. So question 2 involves an experiment that measures fuel consumption at various speeds for a particular model of car. The data collected are shown in table 1. So we have speed in kilometers per hour, and we can see that the speed is increasing here from 40 kilometers per hour up to 112 kilometers per hour. And underneath here we have the fuel consumption. So and the fuel consumption here, it's a bit misleading, but it's the number of kilometers that you can do per liter. So although it appears that the fuel consumption is going down, in actual fact the number of kilometers you can do for each liter is going down. So in fact, you know, the consumption, the actual amount of fuel being consumed as you increase speed is actually increasing as well. But these values here are the number of kilometers you can do for each liter as speed increases. So you can see when you're doing 40 kilometers per hour, you can do 21 kilometers for each liter. When you increase your speed to 112 kilometers per hour, you can only do 9 kilometers for each liter. So you're using a lot more fuel here. Well, anyway, the first question here just talks about well, you're just finding the correlation coefficient of this data here, corrected 3 decimal places. So you can do that on your calculator. Just key in the data and you'll find that the correlation coefficient is minus 0.957 to 3 decimal places. Okay, so next thing we're asked to do is just plot the points from the table on the grid below. So that should be straightforward enough. You just these are on your x-axis, these are on your y-axis, so just plot the points. So I'm going to try to do this here as accurately as I can anyway. So 40 is 21, so 40 here will be 21, so 20 to 25 here, so that's 22 and a half here, so 21 is just slightly below that, so 40 is just somewhere around here. Okay, 48 then is 16, so let's go to 16, that's going to be somewhere around here. 56 is 18, so 15, let's see, that's 17.5, so it's going to be somewhere around here, just above this line. 64 is 16, so that's going to be here somewhere. 72 we don't have, 80 we don't have, 88 is 13, so let's go to 13 here, so that's 12 and a half there, so that would be 13 would be somewhere there. 96 is 11, so that's going to be here somewhere. 104 we don't have, and 112 is 9, so that's going to be somewhere around here. Okay, so that's it, and you can see there's a fairly strong, very strong actually positive, or sorry, very strong negative correlation between these two. And we have seen that from our correlation coefficient up here. Minus 0.957 is a very strong negative correlation between these two. Okay, so let's do we have to, let's see, draw a line of best fit. Okay, so we need to draw a line of best fit as well. Now it says draw it by eye, but usually what you can do, once you've found the correlation coefficient here on your calculator will also give you the mean of the x values and the mean of the y values, so you just need to know how to do that as well on your calculators. But the mean that I got anyway was x bar, the average of the x's, the mean of the x's here was actually 72, and the mean of the y values is 14.9. So what I can do is actually just plot that particular point. So it's 72 and 14.9, so that's going to be 72, 14.9 is going to be here somewhere. And what you can do then is just put your ruler on this point, and all you got to do is rotate it around this point then to draw your line of best fit. So look, I'm going to attempt to draw this. It's not going to be too accurate because I don't have a ruler and I'm doing it by eye here, but let's see what I can do anyway. It's going to be a little bit shaky, I think. Okay, not too bad I guess, but you should be able to do it a little bit more accurately than that, a little bit neater anyway. Okay, so you get the idea anyway. This is our average, if you like, our mean of our x, our mean of our y. Just put your ruler on here and draw a straight line as best you can through these points. Okay, next one then talks about the slope of this line of best fit. So the slope of that line is minus 0.15, so you can see it's negative anyway. What does this value represent in the context of the data? Well, what it really means is that what slope means is how y changes with respect to 1 unit of x. So whatever's on the y-axis, how that changes with respect to 1 unit of whatever's on the x-axis. So we can see that the fuel consumption here, the number of kilometers you can do per litre decreases by 0.15 for every 1 kilometer per hour that you increase. So if you increase your speed by 1 kilometer per hour, the number of kilometers you can do for each litre is going to decrease by 0.15. So you need to just put that in English here. Let me just write this here. So the number of kilometers you can do per litre decreases by 0.15 for each increase by 1 kilometer per hour in speed. Might be a nicer way of writing that, but this is, you can write it in reverse as well. You know, just say that for every 1 kilometer per hour increase in speed you do, you're going to decrease the number of kilometers you can do for each litre of fuel used. Okay, so that's your slope. Now we have Mary here and Jane, and they both drove from Cork to Dublin. Mary drove at an average speed of 96 kilometers per hour. Jane drove the same journey at an average speed of 112 kilometers per hour. So Jane is driving a lot faster. Each traveled 260 kilometers. They paid 132.9 cents for each liter of fuel that they bought, that they used. Both used the model of car used to generate the data in table 1. Find out how much longer it took Mary to complete the journey. Give your answer to the nearest minute. So what we're looking for here is time. We have average speeds and we have a distance, so we can find each time then. So this is really just, you know, speed is equal to distance over time formula, which means we're looking for times here. Time is equal to distance over speed. Or, you know, you can use this triangle thing here that some people like to use. Speed is equal to distance over time, and this is multiplied, so time is equal to distance over speed. Okay, so let's have a look at each one individually then. We have Mary first, so let's have a look at So the time for Mary then is going to be time is equal to the distance that she traveled is 260 kilometers. Her speed of Mary was 96 kilometers per hour. So that's, when you do that, you get, let me just work that out, that's 2.7083. 2.7083. 3 is repeated, and this is in hours. Okay, so let's have a look at Jane then. So Jane did the same journey, and her time is going to be, distance again is 260 kilometers, and her speed was 112. So when you work that out, you get 2.3214 2857 hours. Okay, so what were we asked? And we have the time it took both people to drive from Cork to Dublin. How much longer did it take Mary to complete the journey? So all we got to do is find the difference between these two times. So you're just going to subtract these two here. So the difference in times, so subtract these two here, and you get 0.3869 0476 33. So you just got to work that out in minutes then. It says correct to the nearest minute, so that's 23 minutes. Just multiply, this is hours, so multiply this by 60 and you get 23 minutes to the nearest minute. So okay, it took Mary 23 minutes longer to complete the journey. Okay, last part then. Let me just move this up first, just a little bit, just in case I run out of room at the end. So okay, now based on the data in table 1 and their average speeds, find out how much more Jane spent on the fuel during the course of the journey. So we've got to find the cost, how much it cost each person for this particular journey. So let's again look at Mary's journey first. Okay, so Mary's speed was 96 kilometers per hour. Now if you go back to the table, you'll see, let me go all the way back up here again. So she was doing 96 kilometers per hour, which means that her fuel consumption is 11 kilometers per litre. Now Jane actually, just the same, going back here again, she was doing 112 kilometers per hour, so her fuel consumption is 9 kilometers per litre. So I'm going to use these figures here, 11 and 9. Okay, so we have Mary's speed here was 96 kilometers per hour, which means her fuel consumption was 11 kilometers per litre fuel consumption. Okay, now how much fuel did she actually use then? She used 11 kilometers. She was using she could drive 11 kilometers and she would use up 1 litre. Now we know she traveled 260 kilometers, so therefore she used 260 divided by 11 litres used. So this is how much fuel she actually used in the journey. Now how much did that cost her then? So that's going to be 260 over 11. This is how many litres she used. The cost of the fuel was 132.9 cents for each litre. So she used this many litres, just multiply the two. So that gives you a total of 3141.27. This is repeated here, and this is cents. So this is how much it cost Mary for the journey. Okay, so now we got to do the same thing for Jane. So let's work on Jane's journey. Okay, so we'll do exactly the same thing again. So she was doing a speed of 112 kilometers per hour, and we said that that means she used she could go 9 kilometers for each liter. This was her fuel consumption. Okay, so how many liters did she actually use then? Well, she traveled 260 kilometers. She could go 9 kilometers and use 1 liter, so we're going to divide by 9. So this is how many liters she used. So how much did that cost her then? Well, it's 260 over 9 liters multiplied by the cost of 1 liter, which is 132.9. So that comes to 3839.3 repeated cents. Okay, so now we have the two costs. This is how much Mary would have spent. This is how much Jane would have spent. So we just got to subtract these two. So the difference, again, you can do that on a calculator. Just take this value minus this value here. So the difference is equal to 698.06 cents. And that's just equal to, we put it in euros, 6.98 to the nearest cent. Okay, so that's it for this question, I think. Yeah, there isn't any more, so that's it.